gentlemen, June 9, and it's about address resolution. So the areas that we are going to go through, we have MAC address, IP, then ARP, resolution protocol, and neighbor discovery. So the main objective of this module is to explain how ARP for IP, V4, and then neighbor discovery for IP, V4, 6. Enabled to explain how ARP and ND enable communication on a network. So mostly two practicals respectively that are used to map the known IP address to an unknown MAC address. So in most of the cases, the MAC address of the devices that are not known. So layer 2 device or switch, or even the end device, the end devices, they use those two protocols. They use those two protocols to exchange the MAC addresses. So the MAC and then the IP address. So destination on the same network. So still, as we are saying, that ARP and neighbor discovery, they are used to map an unknown, to map IP address to MAC address. So the MAC address, that is actually the two, the IP address and then the MAC address. These addresses are for destination, not to the source. Because ideally, when the source is trying to send a frame or send a communication, then its IP address and MAC address it's known. But where the message or where the frame is being sent, that is the IP address, it is known, but the MAC address, in most cases, not known in the first place. So layer 2 physical addresses, their MAC addresses are used for network to network communication on the same network. So if the MAC address is to remain consistent on the source and then the destination, the source and destination MAC addresses within the frame, if that to be maintained or if that to be consistent, then automatically it has to be on the same network. For example, like what we have here. Because when you look at this is our network address, then we have this. It's 192.168.10.1. So the MAC address will remain the same. The way it is sent here, that is how it's going to be received on the destination. But if it's on a different network, then automatically, every time a layer 3 device receives a frame, then automatically the MAC addresses within the received frame, they are going to be replaced. So layer 3 addresses, you can call them logical addresses, still it's IP address. So used to send packets from source to the destination, from source and then to the destination device. So the layer 3 addresses, for them, they do not change. Even if a frame is to pass through 1,000 devices, the IP address does not change. So layer 2 addresses are used to deliver frame from one network interface card on the same network. I've already explained that. So if the destination IP address is on the same, if a destination IP address is on the same network, then the destination MAC address will be that of the device. So still I explained that in the pillar. So when it comes to because this one here, it was on the same network. You can see this on the same network, and this is what we have here, that composed frame at PC1, it will remain the same at PC2. But when it comes to destination on remote network, still I've explained that every time a frame passes through a layer 3 device, which is this one here. Now this will be the source, and then this is the destination. They are going to be, because this device, it's going to do what we call the encapsulation and then encapsulation again. So in the process of the encapsulating the frame again, now these two, they are going to be replaced with, now this will be the source and then the destination. Still we have other two. Other two, it's going to do the same by replacing these two and then replaces with. So by the time PC2 receives this frame, the source MAC address will be E. This is the destination, will be, I'm saying 55, it will be 5555, which is this. So this will be the destination MAC address, and then the source MAC address, it's going to be. So it keeps on, every time a frame passes through or is received by a layer 3 device, then that layer 3 device, its response, it's responsible checking, passing the the best path, and then forwards it to the other destination. So here we have packet tracer identifying MAC address and then IP address. So in this packet tracer, you complete the following objectives. Gather protocol data unit information from local network communication. Still, you can gather protocol data units from units information from remote network. So on the same network and then the remote network. So we have ARP. ARP, it stands for Address Resolution Protocol. So this is address resolution, and then this is overview. A device uses ARP to determine the destination MAC address. The source MAC address are known, but the destination, like right now here, in the first place, this switch, the switch here, its MAC address table is empty. So the MAC address table, it has to be populated. So every time a device tries to communicate through the switch, then its MAC address, it's going to be captured. This is MAC 1, and then the port, it's going to be also captured. Let me also put 1. So now the destination, since it's the first time, the switch, it doesn't know. The switch, it doesn't know the MAC address of the destination. But in most cases, the destination IP address will be known, because as you can see, all these, they are assigned with IP address. So you know that the IP address of this computer, it's this, but you don't know the MAC address. So the ARP, it's going to help that you know the IP address, but the MAC address is not known. So this switch, what it's going to do, just to populate, to flood. And then every switch, once it receives, it's going to compare what's the MAC address. It's going to, what's the destination MAC address. Now that all ports they have received, it's a broadcast, meaning that it's a valid IP address, a valid MAC address, because it's broadcast meant to all computers. And then after that, it will allow, or it's going to send the frame, or now, because now if the MAC address is the frame header is stripped off, then you remain with the packet. So the packet is going to be moved to the network layer, and then once it reaches the network layer, is going to compare what's the destination IP address in the packet header. Is the IP address in the packet header the same as the IP address assigned on this interface? So this is our package. It has the source IP address, destination IP address. In the frame here, before we had source, MAC address, and then destination, MAC address. So the destination was broadcast for everyone. So it will accept and then strips off this header, the frame header, and then you remain with packet header. So this is the packet header. So in the packet header, we have destination IP and then source IP. So the destination IP address, it's going to be compared with the IP address assigned. So in case, let's say the IP address assigned, if the IP address assigned matches the IP address in the packet, then it means that that is the targeted device. But remember, the message that was sent, it's not the exact message that is intended to be sent. This message that was sent on the network is just a address resolution. It's address resolution packet. Eh? It's trying to resolve the address to make the exact a real address. So now, if it's for proving address, and now this one here, they have proved that the MAC that the IP address within the package or within the RP package matches matches the IP address on the network interface card on this computer, then it's this computer to reply back. These other ones, they will not reply back. And once this one replies back, it will be the source. It will be the source. And every time the source MAC address device tries to communicate through the switch, its MAC address, it's going to be captured, and then the port where it's connected. Once it replies back, then still, now, because this is 3, now it means that MAC address 3 is going to be also captured. Now the address, the two addresses are known. And then from there, the end device can actually communicate or send what we call unicast packets, unicast frames onto the designated destination. So ARP provides two basic functions: resolving IP address to MAC address. That the IP address is known, but the MAC address is not known. So the method is that. Then maintaining ARP table of IPv4 to MAC address sampling. So this table here, it is always at the end device, because a switch, it cannot capture the IP address and then the MAC address. It only captures MAC addresses. So, but when it comes to a PC here, it has the table that captures both the IP v4 address together with the MAC addresses. So at the switch, it's on a MAC address table that captures MAC address and then the ports where the devices are connected. So to send a frame, the device will search ARP table to send a frame. I think I've explained ARP table, then for destination IP address, and then the corresponding MAC address. If the packet's destination IP address is on the same network, then the device will search ARP table for the destination IP address, the exact, that if it's on the same network, then the PC here, it will just try to search its ARP table for the destination IP address because they're on the same. If the destination IP address is on a different network, the device will search its address table, ARP table, for IP address of the default gateway. So if there is another, let me assume that this is the router, and then this is another network. So here we have the other computers. On the same network, it will just search the IP address of the exact destination device. But if it is on a different network, then the device, it will search for ARP table for the IP address of the default gateway. Now the default gateway of this network, it is this. For this other network, it's this. So it will find the default, try to look for default gateway so that it can find the way on how to exit. If the destination locates the IP address, its corresponding MAC address is used as the destination MAC address in the frame. So if the device locates the IP address, then automatically the MAC address that corresponds with that address, it's the one that is going to use as destination MAC address. If there is no ARP table entry is formed, then the device, it will have to send the ARP request. And ARP request, it will always send in form of broadcast, whereby all the devices on that network, on that LAN, they will have to receive a request and then process the request. So this is the video that will cover ARP request for MAC addressing. We have another one that will cover ARP reply. So it's a request, all of them they will receive, but one has to reply the request, not all of them that they will have to reply. And the only one to reply, it's that whereby the MAC, the IP, where the IP addresses in the packet match or will be matching the IP address in the on the network interface card or assigned on the network interface card. So it's the one that replies, meaning that it's the target, and then after replying immediately, its MAC address, it is captured. So there is a video, this will cover how ARP request will provide a host the MAC address of the default gateway. Removing entries from ARP table. So these ARP table are not permanent. So ARP entries, they are not permanent in ARP table. So after a while, if the computer is idle on the network, then all the ARP entries, wherever they will be for that computer, they will be removed so that they create room or a space or storage for other active devices. So entries in ARP table are not permanent and are removed when ARP cache timer expires. So once it expires after a specified period, then it is removed. The duration for ARP cache timer, it differs depending on the operating system, the capability of device, and then the nature of the operating system. So ARP table entries can also be removed manually. You go and clear. So most of the time, like manually, if I restart the computer, then automatically whichever that is saved in the RAM, it's going to be released. Or in other words, the RAM, it is always released, and then it is assigned afresh once it boots up. ARP table on the network device, you can use ARP minus A, that is on the PC. So this is R, and then on the PC, ARP minus A, then on the switch or router, you can use show IP ARP. So when you look at the switch here, we have this. This is the router. Because the switch, it doesn't have the switch, it does not have it doesn't have that capability of capturing the IP addresses. So, because it's a layer 2 device, so it cannot deal with layer 3 layer 3 addressing. So you can see that here on the router, since it's a layer 3, the IP address, and then the corresponding port, and then the interface. So this MAC address is for this interface. Now on the PC, as you can see, we have this IP address and then this with the corresponding MAC addresses. And how are they launched? Through dynamic mode or mechanism. Issues with ARP. Issues with ARP. So I talked about ARP requests, that these are broadcasts. They are sent broadcast. They are sent in format of broadcast network. So meaning that if this one here sent, all these they have to receive. You know what it means? And it's not only computer A that is going to do that. Even these other computers, they can initiate the request. If they keep doing that, then it means that the network is going to be overwhelmed with those requests. And what is going to happen? The performance is going to lower down, or the network is going to black out. Excessive ARP broadcast can cause some reduction in performance. ARP replies can be spoofed. The ARP replies can be spoofed. That one can be on a network and then disguise the reply as if it's from legit device. For example, let's assume that a computer is trying to look for the gateway, and the gateway is this one here. This one here may actually disguise this. This computer may be disguised as the gateway, and then all these computers try to send their information to this slate actor, and then they end up being hacked. So enterprise level switches include mitigation techniques to protect against ARP attacks. So still in semester 2, I will show you how to mitigate, how to prevent ARP attacks. Then here we have a packet tracer, where to help you to examine ARP requests, examine switch MAC address table, examine ARP process in remote ARP process in a remote communication. So copper cabling. So this video will explain the process of how IPv6 perform address resolution using ICMP version 6 neighbor solicitation and then neighbor advertisement. So in this solicitation, it's like a request, because in the previous we saw ARP, because ARP is for IPv4, a request and then ARP reply. So here the request it's neighbor solicitation, then the reply it's neighbor. Sorry. Yeah, the request it is neighbor solicitation, and then the reply it's neighbor advertisement method. So IPv6 neighbor discovery protocol provides address resolution. The address resolution that you have IPv6 address, but you don't know the MAC address attached to that. Then router discovery, it can discover the router, where to get, and then redirection of service, still it allows to redirect the service. So ICMP version 6 neighbor solicitation and advertisement messages are used for device-to-device messaging. Solicitation and then advertisement. It's just method. It's just device-to-device messaging to resolve the MAC address issue. So still ICMP version 6 router, because here it was neighbor, it's for neighbors, like PC to PC. But now we have router solicitation and then router advertisement message used for messaging between devices and then the router. So PC and maybe the router there for router discovery. So ICMP redirect messages are used by routers for the better next hop selection, redirection. So if this router doesn't have the services that are needed, then the router can redirect a request to other hop, to the next hop for better next hop selection. So here we have this topology where the two devices are on the same network, and the protocol used, or the requests that are used, it's neighbor solicitation as the request. That this computer, hey, whoever has this IP address, IPv6 address, meaning that the address is known, send me your MAC address. So you know this computer knows the IP address, but the MAC address is not known. and then this PC, it's going to send the neighbor advertisement message. Hi, now it is replying back to this one here. Hi, this IP address. I am this IP address and my MAC address is this. And then once this computer learns the MAC address, that is when it can send the real data or real package to PC 2. So in this packet tracer, you will, because this is packet tracer activity, you will complete the following objective. Part 1, IPv6 neighbor discovered local network, and then part 2, neighbor discovered remote network. So this is on a local network, and then this is on a remote network on different networks. And that marks the end of the chapter.